Speaker mode.
Good afternoon, everybody. Last lecture, we explained how to solve electric circuit with DC sources using nodal analysis. And briefly, it's used to find the voltage at each node. It uses Kirchhoff current law. It's easier if you have current sources. And if it has voltage source in series with resistance, we can convert it to current source and we continue to solve it in a simple way using the matrix. Today we have another method to solve DC circuit. It's called mesh analysis. It's obvious from the name that we use mesh current instead of using the node voltage. It's used to find the current in each mesh. Like the circuit in front of you, to the right, you have I1 and I2. They are called mesh currents. It implements Kirchhoff's voltage law. So to start, we'll review Kirchhoff's voltage law to the circuit shown to the left here. This circuit consists of voltage source V1, resistance 1, and resistance 3. To write Kirchhoff's voltage law, use any one as a reference. I will pick this one, and I'll write V1. The positive polarity, it's located here. Then I move with clockwise direction. Then I found V1 positive also, so B minus. But minus, let's just call this VS, not to confuse. Similar name. So I would say VS minus V1 small. And then I continue, I find also positive. So B minus V3 equals 0. Then I continue. I would say VS minus V1 is equal R1 times I1. Why? Because I1 in this direction and the current flows from positive to negative voltage. So minus R1, I1 minus V3 is equal R3 times I. The same thing when it moves like that. So it will be R3 times R1 equals. That's Kirchhoff's voltage law. So I'm not going to explain, the theory as we did last time. Just let's go ahead, take example, and then we'll go back to look at this problem. Now we have a circuit. You got to count the number of meshes here. You have 3. That's number 1. You assume current. You assume current in each mesh. So since you have 3 of them, you have 3 currents, I1, I2, I3. You should assume the currents in one direction, either clockwise direction or anti-clockwise direction. Usually we would choose clockwise direction, but you are free to choose any direction. Third step, you assume the current direction in each resistor. For example, 3 ohm, let me assume that's in this direction. So it will make positive polarity in this direction. I will assume this one downward, so it will make positive, negative voltage. I assume in this direction, positive, negative. The same thing, I assume the current in this direction, so I have positive, negative. That's very important. Now, each direction for each current, try to find what is this current. Example, I3 in this direction, so this current is equal actually I3. You can write I3. Let's take this one. This current flowing in 3 ohm in this direction, but it has 2 currents actually. I1 is going in this direction, I1. I3 rotating and then coming back like that. But the direction, I take it from left to right. So you can write this current is equal to I1 minus I3, right? That's the equivalent. Well, if you didn't get it, try to find for 6 ohm. 6 ohm, I assume the current in this direction from left to right. I2 is going in the same direction, I3 in the opposite. So the current in this branch is I2 minus I3. Let's look for 8 ohm. The current flowing downwards. I1 in the same direction, I2 in the opposite direction. So this current is equal I1 minus I2. If you do every single step, as I'm saying, as I tell you now, correct, you will never miss the right answer. Now we'll go to the final, not the final step, the one before the final. You are going to write the equation. You are going to write 3 equations. Equation for each mesh. We'll start with mesh 1. Mesh 1 will write the Kirchhoff-Volch law, as I explained in the simple one in the beginning of this lecture. You start with 12. 12 is like your reference. You also are free to choose whatever. 12. Then you go with clockwise direction. You find that positive connects to positive. Okay. So the minus this voltage. And this voltage is equal to 3 ohm times the current. And the current you already prepared for it. It's I1 minus I3. Continue for the same mesh. Mesh is like closed loop, you know. Then you find you have 8 ohm and positive also. So the minus 8 ohm times the current. The current here we already defined it, I1 minus I2. Nothing else. You finish the mesh equals 0. That's your first equation. If you understood it 50%, let's see the mesh 2. Mesh number 2. This one. Choose any one reference. You don't have to choose the voltage source because maybe you'll find a loop or a mesh without voltage source. For example, I'm going to choose the voltage 8 ohm. The voltage across 8 ohm, I'm going to choose as my reference. And the positive in the top, the negative in the bottom. What is the voltage across 8 ohm? It's 8 times the current. The current is equal to I1 minus I2. That's my reference. Then I start going clockwise direction. I find the positive connected to the positive would be minus 6 ohm times the current in 6 ohm, which is equal to I2 minus I3. I continue, then I find the positive connect to the negative, then I add it. So the plus 6 volts equals 0. That will be my second equation. Now you can understand 75%. Let's focus on mesh 3 to make it 100%. So that's mesh 3. Choose any voltage as a reference. I will choose the voltage across 3 ohm. I'll write 3 times the current in 3 ohm is equal to I1 minus I3. Then I start moving with the clockwise direction. I found the positive is connected to the positive, so the minus the voltage across 4 ohm, which is equal to 4 times the current. The current is equal I3. I continue. I find connected to the negative. The first one I face here, the negative polarity, so be plus 6 ohm times the current in 6 ohm, which is I2 minus I3. Equals 0. Now we have the 3 equations and the 3 unknowns. The unknowns are I1, I2, I3. You can solve it using any method. I think I found the solution. Then you can go home, you can check. I1 will be equal to 2.83 M and I2 is equal to 1.83 M. I3 equal to 1.5 M. If you have problem for solving equations 3 unknown, you can tell me, you can send me an email, and I can make you a pre-recorded video how to solve equation 3 unknown. Because we have many methods like Cramer's rule, matrix, whatever. Do you remember in the last lecture when we used nodal analysis where we solve it in a simple way using matrix. Can we do the same thing here? Yes, we do. The last time we were using G times V equal I, conductance times voltage equal current. This time I can use the other rule, which is R times I is equal V. And I'll do it nice way matrix. R matrix is equal to R11 minus R12 minus R13. I'm writing matrix 3 by 3 because I have three loops here, three meshes. So minus R21, R22, R minus R23. The last one minus R31 minus R32, R33. Then that's R matrix. That's I vector, I1, I2, I3, and that's the voltage V1, V2, V3. All right. Let's find the values each end. Our matrix is very simple, very similar to what we did in another analysis. The other ones, like we're finding the sum of the conductance connected to one node. Here we'll find the sum of the resistance in each mesh. Example, mesh 1, you have 3 ohm, you have 8 ohm. The total will be 11. So R11 is equal to 11. Let's look for R12. R12 is the mutual resistance between mesh 1 and mesh 2. Mesh 1 and mesh 2, the common or the mutual resistance is equal to 8 ohm. So I put negative 8 ohm. Minus R13. That's mesh 1, that's mesh 3. The common is 3 ohm between 1 and 3. So I write minus 3. Okay. Let's go to the second row. Minus R21 between 2 and 1 is 8, minus 8. 2, 2, the all resistance, sum of them, the sum of the resistance in loop 2, that's loop 2, you got 6 ohm and 8 ohm, that's 14. So you write here 14 ohm. Minus R23, it's between 2 and 3. That's 2, the 3, the common one is 6 ohm. That will be minus 6 ohm. The third row, you have minus 3, 1 between 3 and 1, 3 ohm, be minus 3. 3, 2, minus 6. 3, 3, the total, 4 and 6, 10, and 3, 13. So I did the R. Actually, when you look at this matrix, you find that it's a symmetric matrix. So if I were you, I'll just do the triangle to the right, and then the other one just the right. Why? Because it will save me half the time. Make sure it's the same. See? Minus 8, minus 8, minus 3, minus 3. It's like a mirror reflection on the diagonal. I1, I2, I3, they are the unknown values. V1, V2, V3, they are the voltage source in each mesh. And the sign of the voltage source should agree with the direction of the current in each mesh. What does it mean? You have I1 and I1 going upward, and the polarity of the 12 volt source is in the top here. It means that reducing current upward also. So it agrees with the direction of I1. So you take it positive 12. So what I will do, I will say V1 is equal to 12. Let's look for the second one. That's the second loop. You have 6 voltage. The polarity of the positive is downward, means I'm reducing current in this direction. And I2 is going in the same direction. So again, it's a positive pulse. So I will put 6 volts here. It means if the polarity of the 6 volts, assume if the 6 volt has a positive polarity in the top, you will write here -6 or -6. Now we'll go for the third one. No voltage source. So it's equal to 0. Okay, you are done with the method. You solve it, find I1, I2, I3. Any question? Easy answer. Yes.
When we were getting our equation from S3, why did we do 3 I3 minus I1 minus 4 I3 plus I3 minus I2? Why not I2 minus I3?
Are you talking about this one? Or, oh, okay. Equation 3, okay. That's 3I1 minus I3. That's the voltage across 3 ohms. Why I1 minus I3? Because if you look at the current here, that's I1 going in this direction. So you have that's 3 ohm. And you have I1 clockwise direction, means it's going in this direction. And I3 is going in this direction. So we'll have I3 in this direction. And you assume the current in this direction. You're assuming because you have to choose one direction for the current. You can't choose two directions. So if you choose this direction, so I1 agree with the direction on I3, the opposite. So say it's equal to I1 minus I3. That will be the current. And then to find the voltage multiplied by the 3 ohm. So you have 3 times I1 minus I3. Then when you go in this loop, you'll find that the positive sign here, going with the positive sign here. If you say why you choose I3, I mean you choose the direction in this way. And then the mesh current I3 is going in this direction, in the same thing. So it's the only current. So I is equal I3 here. For this one, you assume the current in this direction. Again, I2 is going in this direction, I2, and I3 is going in this direction. So the current in 6 ohms is equal I2 minus I3. Now go to the equation 3I1 minus I3. You choose the reference. You can choose another one. And then you start moving with the clockwise direction, you find another positive. So you subtract, it'll be minus 4 ohm times I3. Then you start moving again, you find that you are connected now to the negative. Then you add 6 times the current, which is I2 minus I3.
Okay.
You got it?
Yes.
Okay. And the matrix form is really form. If you simplify this first one, right? So simplify it, you find it's the same as this one. And that's easy and simple. But we see, I mean, it's simple and easy if you have all voltage source and you have current source. Sometimes you will have current source, but if you have a nice current source connected in parallel with this, and you have converted to voltage source and continue. But this is, I mean, the ideal circuit that you can use the matrix form directly. Last time we said that, I mean, we like in nodal analysis, we have everything current source, but sometimes you have voltage source, and then we found it was very helpful. The same thing. We wish we have voltage source everywhere, but we got current source. Is it bad? No, not bad. Actually, it reduces our work. Why? Because what is the objective behind measurement? Is to find the value of the currents. If you have 3 loops or 3 meshes, you have 3 equations. Now I don't have to solve for I1. Because I1, if you make I1 rotating like that, I1 this direction, it's the same with the current source 0.5. So I already know I1 is equal 0.5 amp. So why I'm going to solve for mesh 1? The solution is given. So what should I do? I should solve for the other 2 loops. I will write again the equation. I will say that R1, when you write the equation for the 3 mesh, what are we going to do? R12 minus R12. if you want to write the equation for the whole thing, that's what it's supposed to do. But now we are not going to solve for I1. We are not going to solve for. So you don't need this one. You don't need this one. You do that, and then write the equations, whatever left. Minus R21 times I1. What's R21? 2, 1, it's between 2 and 1, which is 6 ohm. Times I1. You know I1, 0.5. So I 0.5. Plus R22, which is 14, times I2. Minus R23, 23 is equal minus 6 times I2. Equal V2. V2 is equal 6 volts. So you can reduce this one, 14 I2 minus 6 I3. And you have 6 and here minus 3 plus 3 be 9. Right? Oh, there's a mistake here. 2, 1 is 8 ohm, not 6. That's 2 and that's 1. Nobody correct me. You guys have to, maybe I can do mistake. Just that would be 10. That would change the solution. R21 is between 2 and 1. That's 12. So that's one equation. Second equation here, minus R31 between 3 and 1, that's 3. Times I1, I1 is already 0.5 and minus R32, that's 3, that's 2, minus 6. I2, R33, the total for 13. I3, no voltage source. That will be minus 6 I2 plus 13 I3 equal 1.5. And solve two equations, find I1, I mean I2 and I3. So actually it's simple. So when you have current source, sometimes you'll have current source with parallel resistance. If you have something like that, and that's the rest of the circuit, doesn't matter. You just change this one into voltage source in series with the same R. And you continue, then you write the equation in the matrix. But I didn't do that because I don't have something in parallel. You cannot say this in parallel with this one because there's the resistance in a way. It has to be attached to it, nothing between them. Okay, if this is the way, just do what I did. All right. Now I will talk about something else. We'll finish with the mission. This. Yes. This one? That's, you have 6 volt here and you have minus 8 times a half. It would be equal to minus 4. And then I move it with the 6 become 10. Now we'll move to a theory in circuit analysis. It's called superposition. Actually, superposition is not the only theory used in electrical engineering. It's also used in mechanical engineering, hydraulic engineering, and all engineering. What does it mean, superposition? Superposition, it means that if you have a linear system and there are many inputs to the system, like if you have a system and you have like many forces like F1, F2, F3, and you want to find the effect all of them, and you know that this system is linear. So what you do, you say, okay, F2 is equal 0, F3 is equal 0, and only apply F1, and then find the effect. Whatever happens, move something or cause deterioration, something, let's say move something for distance. And then you apply F2, and you put F1 and F3 equal 0, and find F2. And find the effect, and then the last one, you apply F3 and you put the other two zero, and then you add the effect of the three of them. This is only applicable for linear system, and we have linear system. The same thing here for electric circuits. It's a simple one. It could be more complicated. I put in the homework more than that, but just to understand the concept. You got voltage source and current source, and it's required to find I2, the current information. So what I will do, one time I apply the voltage sources, 10 volts, and I will kill this one. And one time I will leave the 2 amp and I kill the other source. The voltage source, you can kill the voltage source, make it Vs equals 0. What does it mean the voltage is equal 0? It means short circuit. It means like if you have a switch, just close the switch. What does it mean? It means if you want to kill this voltage source, just you put short circuit on it. Once you put short circuit on the power supply, it's not there anymore. Why? Because the current, the electrons will prefer to flow in a wire than flowing in some element has resistance. Because the wire has zero resistance. It will just go through it. So that's why we represent it as a short circuit. When you have a current source in any direction, and if you want to kill it, it means you want to find I equals 0. What does it mean I equals 0? It means no current go through it. So you open the circuit. It will be represented as open circuit with switch off. So if you want to put Vs equals 0, just put switch closed across it and remove this one. If you want to put the current is equal to 0, you remove the wire completely. Well, saying that, let's just start solving this one. I want to find the current I2 in the resistance 4 ohm. Let's start with the source 10 voltage. So I want to put this current is equal to 0. I'll sketch the circuit again and I'll show you how to be done. That's the circuit. 10 voltage, 5 ohm, 2 ohm, 4 ohm, and I'd like I2. Well, I will write I2 dash because I'm going to get two currents. I2 dash due to the voltage source and I2 double dash due to the current source. Then I add them. I get that. Yes. I put here the voltage 10 voltage and the current source here. I remove it as over. Oh, the positive. Oh, you're right. Okay, good. Yeah, positive in the top. Yeah, that's right. So I remove the current source. It is like nothing there. So the current will go like that. Nothing will go in the oven, of course. That's the current. I will call it I2 dash. That's already called I2 dash. Because in the same direction, the I2. I2 dash is very simple. Because you divided the voltage over the total resistance. So we're connected in series. So you have 10 voltage divided by 5 plus 2 plus 4. 11. So I2 dash is equal 10 over 11 amp. Now I'll go for the current source. I will sketch the circuit again. And just put I2 to remember the direction. That's the voltage source. And that's the current source. Now I want to kill the voltage source. I want to put 0. So I make short circuit. So no current will go there. So you replace, actually, when we say you're going to kill the voltage source, just replace it by a wire. Just simple, put wire. If you want to kill the current source, remove the wire. That's easy, right? Current source, you remove the wire. Voltage source, you add the wire. Okay. Now you want to find the current in 4 ohm. So what you will do? What do you think? How can you find the current here in the 4 ohm? There's 2 lectures before that lecture. This current, what will happen to this current? This current going in this direction, then some go there, some go in other direction, right? So it's like a current divider. I will sketch it in a nice way. 2 and 4, they are 6 ohm. It's in parallel with the 5 ohm. And then the current going through both of them in this direction, 2 amp. So current will go there, some they go in 6. The current in 6 ohm, call it for example IA. What's IA? It's equal to the total current, which is 2 amp, times the opposite resistance, 5 ohm, divided by the sum of both. That will be equal 10 over 11 amp. But I know that I2 should be in this direction. And I called this one I2 double dash. So I2 double dash is in the opposite of IA, so I can write I2 double dash is equal minus 10 over 11. Right? So the total current I2 is equal I2 dash plus I2 double dash. I2 dash is the one due to the voltage source, and we got it equal to 10 over 11, right? But 10 over 11, and this one I told minus 10 over 11, so it's equal 0. So the current is equal 0 on this resistance. No current. Any question? Is a simple one. When you solve the homework, you'll find a little bit more complex, but the same thing. Yes. Which one? I2 double dash? Well, I mean, do you understand this current divider circuit? Did you know that we got IA is equal 10 over 11? Right? Because the 2 amp is in, and you have 6 ohm, you have 5 ohm, so you want to find the current in the 6 ohm, so you multiply total current times the opposite resistance, which is 5, the other side, divided by the sum, right? So I got 10 over 11. 10 over 11 in this direction. That's 10 over 11. But I2 should be, I didn't assume it, it was given in the problem. Find I2. So it's imposing me the direction. So I said, okay, so the corresponding current, according to the direction given to me, it would be the minus. Yeah. You got it? Did I give you attendance? Last lecture, I explained voltage source, current source equivalence, right? One in parallel, one in series. We know that. Let me review quickly. I mean, if you have voltage source in series with the resistor, then you can convert it to voltage source. You divide this V by R, you get the current value, and then this resistor, you attach it in parallel to the current source. If you have current source in parallel with the resistor, and there is nothing between them. Well, let me just insist on this one. If you have a current source like that and resistor and another one, you can convert it. You can. This current source has to have like a nothing with it in this branch. Nothing like this one. Has to be pure current source branch and resistant in parallel. So you multiply the current times the resistance, you get the voltage, and then you put this resistance in series with the voltage source. Okay. Is it helpful? It's very helpful. Sometimes when we are solving the mesh analysis, using mesh analysis, you find like you need voltage source, but you find current source in parallel with this, and then you convert it, and then you continue in this way. The same issue, I can also face it in nodal analysis. And sometimes you can use the transformation between current and voltage source to solve the circuit without anything else except Ohm's law. Let me give you one Here we start, this is a circuit, and is required to find the output voltage VO across 8 ohm. So what we do here, I mean, I found that this current source is in parallel with the resistance, so I convert it to voltage source. I multiply 3 times 4 is equal to 12. Observe the polarity of the voltage. The current 3 amp was downwards, directed downwards, so the positive polarity of the voltage source should be also downward on the bottom. And the 4 ohm, I put it there. And of course, I mean, you will not have the current source here. So you have that's what I did. I converted this current source into voltage source. Then I complete the circuit. Then I put the 2 ohm, the 8 ohm, 3 ohm, the current source. I'm not done yet because you have to find the output voltage. Well, let me check if you understand. I want you to give me the second step. I had fun that did the first step. Now try and take on the second step, reduce it more using the conversion between voltage source and current source. Whoever finishes problem and gets the output voltage value using this method and show me that, will get the force. The first one. Every lecture will have to have somebody. Right. The first. Be fast. The simplification what I did here. What's the advantage?
Yeah. Where are you
starting? That's a starting. That's a circuit was given like that. Then I start this current source in parallel with the resistance. I convert it to voltage source with the resistance. So this red bar comes here. Convert it to this one. I can do more simplification. I'm asking you to do more simplification. It helped me a little bit. You can do more. You can do like 1 or 2 more steps and then you're done. The objective is to find the voltage across 8 ohm by using Ohm's law and this transformation.
use 12 automatically to do the 4 amp?
Go ahead, do it. You did it? It sounds right. You're on the right side. Does anybody understand how we transform from 1 to 2? I can explain it again.
What are you doing on the right side? The 12 volts going to 4 amps.
This one or this one? Which side?
We can see your cursor.
Oh, are you talking about this side or this side?
The 12 volts in figure 1.
In figure 1.
Is that a different communication?
No, that's we start by circuit in figure 1. And then I reduce it to a figure 2.
So you're changing 4 ohms, 3 amps to 12 volts.
To 12 volts 4 amp. 12 volts is 4 ohm. That's what I did.
And you're also changing 12 volts to 4 amps on the right side?
No, I didn't. Oh, yes. Yeah, I see what you mean. You have 12 voltage and 3 ohm here. That's right. I divided 12 by 3. I get 4 amp. You're right, completely right. And 3 ohm, I brought in parallel. I did 2 transformations. You're right. Like this one, I transformed the current source to voltage source. That's right. And 12 divided by 3, I got 4 amp. And then the 3 ohm, I made it in parallel. Yes. You're right. Yeah. I did 2 transformations. I'm sorry, I didn't explain the one to the right here. So I did 2 transformations.
What I don't quite understand, why are we getting rid of one current source to make a voltage source, and then getting rid of the voltage source to make a current source?
All right.
What are we doing?
What we try to do when you do transformation, you try to make all of them like one type, voltage source, current source, in the end. But if you do only transform this one and you leave the current source here, I mean, you have something here annoying you in the middle. You see what I mean? I mean, okay, the old idea, you want to make all of them like voltage source or all of them current source to help you on the circuit. So I did transform this to current source to be like that. But I found this current source. It's something that annoying me, 2 ohm. If I can get rid of it, it would be easy. So I converted that first to voltage source. Then now you can add 4 ohm and 2 ohm together, and you make it 6 ohm. When you make it 6 ohm, then you can convert it back to current source. So you have 12 voltage and 6 ohm. You have 2 amp in parallel with 6 ohm. 2 finished, it's gone. And then you got your resistance, 8 ohm, and you got your other current source, 3 ohm, 4 amp. So you have a circuit only has one node and all current source. You want something in the middle, all this one node. You think it's 3 nodes, no, it's one. Because I mean, there's nothing between them, which is really nice. And look more, I mean, if you consider it like one node and branching, you have 2 amp down, right? Out. You have 4 in. You can put it in the side, 4 amp. Because going to the same node. And then you got the rest 6 ohm. And you got 3 ohm and 8 ohm. So all just hanging from one node. Now you simplify 2 downwards, 4 amp upwards, so you can say that you can cancel one of them, and you will say just this is 2 amp in, right? Now you have 3 ohm and 6 ohm in parallel. They call it same load. So find the equivalent. It would be 3 times 6 divided by the sum 9 by 3. So you got 2 ohm. So you can replace 3 and by 2 ohm. And you have 2 amp, and you have the 8 ohm. I mean 8 ohm. That's it. Then now I mean you have 2 amp in, then the current will be divided. Current divided again. So I will be equal to the total current 2 times the opposite resistance 2 ohm divided by the sum 2 and 8 is 10. And then you got it. It would be like 0.4. You got 0.4 amp, then multiply it by 8, you get the voltage. And it's done. So the question is really good, because I mean, why are we converting voltage to current? And current voltage is just not like a practice conversion. No, you try to reach a goal to make it easy and simple to solve. And it would be nice if we have all of them current source. But I mean, I did transform that in the end current source, but I got to first get rid of this resistance. How to add it, convert this to voltage source and make 4 and 2 add it. Yes.
I was going to ask you left it.
Oh. So I mean, I want current source. I mean, to be there, all of them, but I can't leave this, because if I left it, let's say, I mean, just for a second that we left it. What is the advantage? When you do it, you'll find it's still not easy. I will sketch this conversion to current source. That's 4 amp, 3 ohm, and then you got 8 ohm, 2 ohm, and you have current source, 2 ohm, 4 ohm. All are current source. But do you think it's still easy? Yes, we can solve it, but you are going to write equation. If you have current source, so we use the first method that we explained previously, the nodal analysis, and make two by two matrix. But I mean, you can get rid of this too if you convert this to voltage source and you add it to it. It made life easy. It made in the end, you have only one current source and 2 parameters. So it needs really, I mean, like, it doesn't need skills in man. No, it's like, I mean, that you have focus, you know. How can you simplify it? You have to focus and think about it. That's all. It doesn't have any complexity. Yes. 4 ends on the right. Yeah. So you want to understand how we got rid of the 4m, right? All right. You have here 4m, and you have here 2m. You know how we got to m? All right. So if you have these three junction, it's only, you can consider as one knot. So the 4 is going in this one, 4m going in, and the 2 going out. So in 4m, out 2m. What is the result? 2m. That's why, I mean, I canceled the 4. I said 4 minus 2, because I mean, I take the direction in. 4 plus minus 2, the equivalent would be 2m. And the 4m, I mean, if you want to know how we got the 4m, it's from the beginning here. Okay. That's, I mean, easy always with the current source. I mean, just find the direction. The in is positive, the out is negative, and the algebra, and then you go. Do you have question that? Any question that? It's really, if you know it, it's simplifying many cycles. Well, I mean, the homework, that's the homework, and the end of the slide, I will upload it with these slides. That's from the textbook, the mesh analysis, you practice, and the superposition, few problems. And I didn't find, I mean, good problems in source transformation. So I just give you this one already. Yes. Yes, I can. I will upload the same thing as PDF. I upload PDF. Yeah. So this, I mean, will be like your, let's say. Well, I'm done. Do you have any question? Let's see if we're done with the time or give you a try. Okay. You're free to. Don't forget, please, to sign that.